Welcome to the second module of the course Cloud Computing. Today we are going to discuss about utility computing. So today we see that there is a new age in the computing mechanism. First, there is an explosion of domain based applications, new very fresh applications which are very specific for every domain are being created and deployed. Then we see a proliferation of devices. New devices are coming up every day, hardware is becoming better and bigger. Therefore, to support these hardware, the applications and the software are coming up. Hence, the superior software methodologies. With a proliferation of hardware devices, a better methodology, a standard methodology is required so that the devices are well supported by the software. This whole arena of hardware and software is supported by the communication bandwidth. Without the bandwidth, it is not possible to communicate, and a device cannot survive on its own separately. Therefore, it requires communication, and the communication bandwidth is helping the proliferation of both software and hardware. Further, there are general purpose graphic processors which are fast, which are capable of implementing quick graphics, and hence this is another help in the development of the new computing technology. Virtualization, which requires or which implements the hiding of the underlying details from the users of an implementation, is another reason which is helping the whole new age of computing in leveraging the hardware. Last but not the least, the recent advancement of multi-core processors helps the whole gamut of hardware and software to move forward faster. But before that, let us see how this whole thing came about. In 1961, John McCarthy, he was an American scientist, he gave a talk in MIT and he said, if computers of the kind I have advocated become the computers of the future, then computing may someday be organized as a public utility, just as the telephone system is a public utility. The computer utility could become the basis of a new and important industry. While the mechanism he talked about was public computing or utility computing for the public, it was absolutely unheard of. But before we understand that, let us look at what is an utility service. Utility service is a telephone service, a newspaper service, an electricity service. What is common among all these services? The commonality among these is that the services are offered at a cost. The users are not required to know where from the services are being offered, who are the people behind the service facilities, how the thing is being manufactured. Let us take the example of newspaper. We pay for everyday newspaper, but we are not aware of the printing press where the newspaper is being printed. We are not aware of the editors where they are sitting and editing. We are not aware of the journalists who are creating the news. So therefore, these are all, even electricity has a similar mechanism. So all these are called utility services because the users are not required to be burdened with the nitty-gritty or the details of how the service has been generated or manufactured. They simply use it and they pay for the amount or the proportionate to the amount that they have used. So if I subscribe to one newspaper, I pay for one newspaper, which is actually a very small amount in comparison to the whole gamut of mechanisms required to create that newspaper, but there will be many such readers, and together the whole set of people will pay for the newspaper. So, what John McCarthy basically indicated is that why don't we have a computing as a service like the utility functions, like the utility services. With this thought as a seed, the concept of utility computing started developing and eventually perhaps has developed to what is known as a cloud computing. So, Wikipedia definition of utility computing says a service provisioning model in which a service provider makes computing resources and infrastructure management available to the customer as needed and charges them for specific usage rather than a flat rate. This is a very important part of utility services and therefore utility computing. So, utility computing is having a service for computing. Utility computing is an on-demand service. The utility model seeks to maximize the efficiency. So, using this utility, we would be able to serve many more people than a normal hardware or a software can serve. Further, utility computing is the packaging of resources, all resources. It should be the hardware resource, software resource as well as the storage resource. The major advantages of having a utility computing is for the users the cost is very low and they do not need to invest anything initially on any hardware or buying a software, and the computational resources will be available and will be rented to the users. So, the cloud computing as we know today only partially fulfills the requirements of the utility computing. So, what is cloud computing? Let us look at the definitions of cloud computing. National Institute of Standards and Technology, NIST, defines cloud computing to be, it is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. These resources can be networks, servers, storage, etc. that can be rapidly provisioned and released with minimal management effort or service provider interaction. This cloud model is composed of 5 essential characteristics, 3 service models and 4 deployment models. So, the important terms here are enabling ubiquitous, convenient, on-demand network access. To what? To a shared pool of resources which can have rapid provisioning and quick release without much involvement of the service providers. There are many other definitions. Everybody, all researchers, all the industry, everybody comes up with a definition of cloud computing or what a cloud should be. Let us look at a few more definitions. So, Gartner defines it as a style of computing in which scalable, elastic, IT-enabled capabilities are delivered as a service to external customers using internet technologies. IBM, another big entity in the cloud arena, defines it as an emerging IT delivery model. Cloud computing can significantly reduce IT costs and complexities while improving workload optimization and service delivery. Similarly, let us look at a few other definitions. Gartner says that it is a style of computing in which scalable, elastic, IT-enabled capabilities are delivered as a service to external customers using internet technologies. IBM and AT&T are 2 other big houses who also have their own definitions of cloud computing. Professor Rajkumar Bhuiya, a very well-known researcher in cloud computing, also has defined cloud as a type of parallel and distributed system consisting of a collection of interconnected and virtualized computers that are dynamically provisioned and presented as one or more unified computing resources based on service level agreements established through negotiation between the service provider and consumers. So, the system is known as a parallel and distributed system. It consists of a collection of interconnected and virtualized computers that are dynamically provisioned and is based on service level agreements. So, from all these we understand that cloud computing is a mechanism which requires dynamic provisioning, which is a kind of distributed systems. It requires internet technology or some kind of networking, and it is a pay as you go model. So, let us now look at how this all cloud computing started from, where from it started. So, if we look at the history of cloud computing, initially there were very large computers. ENIAC is one of them, which was a room full of computer, but it is said that that is also the first of the data center since it filled a room. Then the industry started developing data processing. The amount of data in those days were maybe in megabytes or gigabytes, but very large data. On a time shared manner, the industry started doing this large data processing. Then came the concept of distributed computing, in which we had grid computing, then we had cluster computing, and now we have cloud computing. So, if we look at this, then we see that cloud is a part of the distributed family, just like grid and cluster. To be more precise, cluster enhances the implementation of cloud computing. Now, let us look at the overview of cloud computing to see what it consists of. So, cloud computing uses resources such as compute and storage servers, networks, services and applications. It requires infrastructures, which is distributed infrastructure, resource virtualization, autonomous systems. It has a specific set of attributes: on-demand self-service, rapid elasticity, resource pooling, broad network access and measured services. It follows a set of deployment models which are public, private, community and hybrid cloud, and it has a set of delivery models which are software as a service, platform as a service and infrastructure as a service. First, let us look at the resources. So, in resources we see that there is computing and storage resources, which are basically the servers. These servers will be contained in one or a number of such big large housings which are called data centers. Then we will have networks, we will have services and we will have applications. First, we will talk about the storage and servers. Now, to provide the service in a cloud environment, we require a large number of servers. These are compute servers, which means that there will be large amount of computing requirements, and the service provider need to acquire very large number of big servers and put them together to create what is known as a data center. So, in a data center, we should have large number of big servers, and we also need very large amount of storage, since these will be used by a very big number of users. So, where we store these servers and the storages is called a data center. Let us see what is a definition of a data center. According to Wikipedia, a data center is a facility that is used to house computer systems and associated components such as telecommunications and storage systems. It generally includes redundant or backup power supplies, redundant data communications connections, environmental controls, examples air conditioning, fire suppression, and various security devices. So, basically a data center is where we would store, or a service provider would store all the servers, and we will connect these servers and the storages using the necessary communication mechanism. The networking will be done among these servers, and these servers will be accessible remotely from outside. The idea behind a data center is, if we congregate all our resources in one place under one roof, it is easier to manage them, and this can be this whole set of resources can be accessed remotely from outside by the average client. Now, if we look at this picture, this is actually a data center in a very reputed house. So, this is how large a data center should look, and here in this data center there will be a very large amount of servers. Now, if we look inside a data center, this is how a data center should look like. Each of these are racks. Each of them will house servers inside them. If we open these racks, we will see a set of servers housed inside the racks. So, next, these servers and the storages are connected using networks. A very important role is played by networks, since the storages should be connected to the servers and the servers should be connected to each other, and the whole setup should be allowed to be accessed from outside by the clients. So, a very important part of having a data center and being able to provide the service from the data center is that the networking is done properly and appropriately. Next comes the concept of services. Services is basically what is meant to be web services. We know that web services can be provided remotely by service providers, and there is a specific mechanism that is used for providing web services. A similar concept is used in cloud computing, where the resources are gathered in the form of a service, and these services are deployed over the internet to the users. So, the concept of a service is essentially from the web services concept, which has been adopted by the cloud computing mechanism. Next are the applications. These services are essentially service of applications. Primarily applications, there are other types of services that we will be talking about later on. So, if I develop an application, then this application will be provided to the outside users over the internet as in the form of a service is the concept of cloud, and these applications will be deployed in the servers and the storage. These servers and the storages will be housed in a house called the data center, and there will be an appropriate networking making all the services available to the users. So, the cloud is basically a concept where we pull a number of resources together, we put them in a place, we call that a data center, we connect these data center through a proper networking, and we provision these resources to the outside world. So, in summarizing today's lecture, we have seen that cloud computing is basically a part of or a kind of utility computing. The utility computing concept is quite similar to utility service, where we pay for the amount of usage that we have consumed, which means that when we offer cloud as utility computing, we will be using the computing or the storage as per our requirement, and we will be paying for that specific amount of resource that has been used. Next, we saw various definitions of cloud. Since cloud is a new concept, and since cloud has created, as we have seen in the earlier module, cloud has created a very big response from both the academia and the industry, many definitions of cloud actually is available. We have seen some of these definitions, but in essence what all these definitions point to is that the cloud computing should be dynamically provisionable set of resources that should be made available to the users through network, which some definitions mentioned to be an internet. And the other point that comes through from all the definitions is that the environment should be a virtualized environment. Then we looked at the overview of cloud, in which we essentially saw the NIST mechanism of cloud computing, which says that there are a set of resources being used by cloud. There is a definite infrastructure required by cloud. There are basic characteristics which are known as essential characteristics of cloud computing. There are a set of deployment mechanisms or deployment models, and there are a set of service models through which the services are provided to the outsiders. Finally, we looked at the resources in cloud. Essentially, it is how or what a data center is, how data center houses the mechanisms. In case of data center, we saw that it houses a lot of server and storage components interconnected using a networking mechanism, and from where the services of applications and all other services can be provided. In the next module, we will take a look at the other components of the overview of cloud, which is the infrastructure component and the essential characteristics component.